So this is going to be lesson 3 in our solving equations unit. It's going to be on combining like terms. Your homework will be pages 7 to 8. So in our note packets, if you flip to page 7, that's where our combining like terms and equations will be. Now, this isn't anything new. We've done combining like terms before in class, so it's going to be a little review again in case you're a little rusty. So if we look at our first 2 examples, we want to solve for our variable, right? So in our first one, example 1, I have 3n plus 9 plus 4m equals 2. So I want to get the m by itself. To start off, I'm going to split my 2 sides. Now, if you notice, 3m and 4m, we can combine. They have the same variable. So we can add those 2 together, and we'll get 7m plus 9 equals 2. Now we can solve. We can subtract 9 from both sides, and I'll get 7m equals negative 7, because 2 minus 9 gives you negative 7. We're going to divide by 7 on both sides, and I'll get m equals negative 1 for my first example. In my second example, I'm going to split it up again. I have a 5x and a 2x. I can combine those to get 7x minus 23 equals 5. I'm going to add 23 to both sides. I'll get 7x equals 28. Divide by 7, and you'll get x equals 4. If you look down to the next 2 examples, let's do example number 3. I'm going to split this up. Now, I have a 3s, and I have a negative 6s. It's really important that you watch the sign in front of it when you're combining. So since I have a 3s minus 6s, I'll have a negative 3s minus 5 on this side after combining like terms equals 4. So now I can add 5 to both sides, and I'll have negative 3s equals 9. Then I can divide by negative 3 on both sides, and I'll have s equals negative 3 as my answer. So, I want to flip to the next page now and look at some of our word problem examples. We're going to write an equation, simplify, and then solve. So looking at our first example, it says you and your friend's lunch cost $19. Your lunch was 3 more than your friend's. How much was your friend's lunch? So when we're talking about word problems, we always want to define a variable first, what we're looking for. So in this case, we're looking for how much our friend's lunch cost. So I'm going to say cost of lunch. And I'm just going to call that X, right? The cost of our friend's lunch. So we know that both of our lunches combined cost $19. So clearly we're going to add the totals of our lunches up to get 19. But it says my lunch was $3 more than my friend's. So if my friend's lunch costs X amount of dollars, I'm going to add my lunch to it. I'm just going to put this in parentheses. So my lunch was my friend's lunch plus $3 more. Don't you agree that that would be the total for your lunch? And then it would equal 19. And now we can solve to figure out how much our friend's lunch costs. So since I have an x and another x, I can combine those, and I'll have 2x plus 3 equals 19. I can subtract 3 from both sides, which gives me 2x equals 16. I can divide by 2, and I'll get x equals 8. And we defined x as our cost of lunch, right? The cost of our friend's lunch. So over here, I can write that your friend's lunch your friend's lunch costs $8. Now, if I was to ask you how much your lunch costs, right? It's telling us in the problem up here that your lunch was 3 more than your friend's, and how we wrote it right here, we can figure out that your lunch is just the 8 plus 3, which gives us $11 as your total for your lunch. And a way to check, we could add our $8 and our $11 and we would get $19 as our total. Looking at example 2, it says Mrs. Gradner's grandparents had birthdays in consecutive years. This meant that when her grandmother was 41, her grandfather was 42. They were consecutive numbers. They came after each other. In 2012, the sum of their consecutive ages was 167. How old were her grandparents? So I want to set a variable first. So since her grandmother was younger, a year younger than her grandfather, I'm going to say let her grandmother her age equal X. Okay. So if her grandmother's X and her grandfather's age is consecutive, well, looking right here, it's just plus 1, right? So we can add her grandmother plus 1. So this is going to be her grandfather's age. And we know the sum of both of these will give us 167. So now I can solve. I can combine my x's, and I'll have 2x plus 1 equals 167. I can take 1 away on both sides. I'll have 2x equals 166, divide by 2 on both sides, and I get x equals 83. So if we said x is her grandmother's age, we know her grandmother has to be 83. So over here, I'll write grandmother is 83. Well, what about her grandfather? If her grandmother is 83 and they have consecutive years, we can look right here. We said x plus 1 was her grandfather's age. So we can just plug that in. So 83 plus 1 would give us 84. And a way to check that, we could just add those ages up and we would get 167.